Okay, so an inequality is when we're comparing numbers. So we're going to use these symbols. So this symbol right here is the less than symbol. And that means we're talking about numbers that are less than something else. And we'll see some problems with that in just a second. Here we have greater than. So then we're talking about numbers that are bigger than a certain number. Then we would have a less than or equal to. And so that means that we're talking about numbers, yes, that are less than, but it can also include whatever number we're talking about. And then we have greater than or equal to. Okay, and so we're talking about numbers that are greater than, but also can equal to it. So what I mean by that is, so if I said x is less than 3, okay, that means we're talking about every number less than 3. So 2, 1, 0, -2, -5, -100, whatever it is, right? But it's got to be less than 3, right? If we're talking about x is greater than 3, now we're talking about all numbers bigger than 3. So 4, 5, 6, 100, whatever. If we have x is less than or equal to 3, now we're still talking about 2, 1, 0, -1, but we also now include 3, okay? And then if we have x is greater than or equal to 3, again, it now includes 3, but now it's still everything also bigger than that. So 3, 4, 5, 6, okay? So we're going to take our equations and be able to solve to look like this. And then we're going to graph this information. So if I were to graph x is less than 3, okay? So here's 0, so 3 is to the right. When it's just less than, so it does not include the 3, we use an open circle, and then we show what direction it's going in. So it's everything less than. So see how the arrow is pointing to everything smaller?
Yeah.
Okay. If we are showing that it's greater than 3, it's still an open circle because it's not including 3, but now it's greater than. So the arrow has to point to numbers bigger than 3. If we are less than or equal to 3, now we're including 3. So we're going to have a closed circle at 3, but it's still less than, so the arrow still goes to the left. So you see the difference between this one and this one?
Yeah.
Right? Open circle, closed circle, because it's equal to. Okay, and then we have equal to 3 here, so it's a closed circle, but it's greater than, so the arrow goes to the right. So they're similar, this one and this one, but this is a closed circle because it's equal to. Okay? All right, so let's look at a quick example so we can see how to use this. All right, so I'm going to do 2x minus 5 is greater than negative 11. Okay? So we're going to solve this just like we did yesterday with our two-step equations. We think of this as two sides. We hold on to our variable, and we get rid of that negative 5. So the opposite of negative 5 is positive 5. Okay? So the 5's go away, and we're left with 2x is greater than. Now, because I have some negatives in there, I might want to use my T-chart like I showed you yesterday. So the 11 is negative, the 5 is positive. So because they're on opposite sides, that tells us to subtract. So I know my number is going to be 6. And then because 11 is bigger, it's negative. Okay? Now, I can start dealing with that 2. So remember that 2x tells me to multiply, but we actually have to do the opposite of that. So we're going to divide by 2. And so I get x is greater than 6 divided by 2. 6 divided by 2 is 3, and 1 negative stays negative. Okay, so does all of that make sense?
Yes.
Good. Then we go to graph this. So now negative 3 is on the left side because it's negative. It's greater than, so that means it's just an open circle because it does not include negative 3. And so now we're talking about all numbers greater. So think about when we're thinking about greater, especially compared to negatives, we want to go towards our positive numbers because those would be greater than negatives. So we're going to the right, okay, because it is greater than. Also, as long as the equation is written with the variable first, your inequality actually shows you which direction to head. Okay, so just a kind of an easy way to remember. But that only works if the variable is at the front. Okay, so far so good?
Yes.
Okay, good. All right, let's look at another one here. Can't see it. There we go. All right, so again, we think of it as two sides. We hold off on touching our variable until we get rid of this positive 8. So the opposite of positive 8 is negative 8. So we have x over 3 is less than 2, because 10 take away 8 is 2. And then because this is a division problem, we're going to multiply by that 3. And so we get x is less than 6. And so then when we graph that, 6 is on the right. It's less than, so we have an open circle. And so then it's everything less than 6. So that's 5, 4, 3, 2, right? All the way to the left side. And the inequality is even showing you that direction. Okay. So did those two problems make sense?
Yes.
Okay, good. So now I'm going to make it just a slightly bit harder. Just a quick other rule that you need to remember when dealing with inequalities. So let's look at this problem. Okay, so first things first, we start by subtracting the 2. Okay, easy enough, just like our rest of our problems. But here's where it gets a little trickier. This is a multiplication problem, so we're going to divide, and there's a negative 3 on this side. So because this is negative, okay, because that's a negative 3 that we're going to divide by, my inequality has to flip. So because I'm dividing by a negative number, my inequality changes. It flips over. So now it is greater than. This only happens, and this is where you kind of have to really remember, this only happens if we're multiplying or we're dividing by a negative. Okay? Only happens when we're dealing with negatives. All right, so we get that x is now greater than or equal to negative 4. Okay? And so when we go to graph that, here's negative 4. It's a closed circle because it's equal to, and if it's greater than, that means it's going to the right. Okay? So we just have to remember that rule about negatives, and this only happens with inequalities. Okay? And it only happens for multiplying and dividing. Does that make sense?
Yes.
Okay, so let's look at one more, and then I'll have you try some on your own. Okay, so let's look at okay. So we're going to hold off on our variable. We're going to subtract 2. Okay, so now we have this. All right, so because this is a division problem, that means we're going to multiply. And so what is on this side that we need to multiply? We need to multiply that negative, and we need to multiply that 10. Okay, so because this is negative, that means our inequality is going to flip. And so we are multiplying by a negative 10. And so now we get x is less than negative 70. Okay. So here's negative 70. We have an open circle because it's just less than. And so because it's less than, we're going to the left. Okay. Do you remember these from when you were in school, in live session school?
Nah, I didn't really pay attention.
Okay. But does this make sense?
Yeah, yeah. It looks familiar. I've seen it a couple of times.
I mean, you learn it kind of uh, every year starting in like 7th grade. So you've probably seen it. You've probably seen it a little bit.
Yeah.
Okay. So let's have you try one. All right. So let's try. Let's go with 15x plus 6 is less than negative 54. All right. So try this one. Did you come up with an answer?
No,
Or are you
mate.
still working?
Still working.
Okay.
Oh, I typed it in right.
So you're not going to really be, well, this one you probably could. Um, but can you just tell me what your answer is?
X less than, I think,
Okay.
-4.
All right. So let's see. So did you subtract 6 first?
Yeah. And then
Good.
cross the 6.
Okay. And so then you end up with negative 60 on this side because you actually add those. And then you divide it by 15. And so is that what you said?
Yeah.
Good. And so then when you go to graph that, it's an open circle and it's to the
To
left.
the left.
Very good. Awesome. All right, let's try another one. Okay, let's try that. Okay, try that. Ooh,
I can't see.
there you go.